I think we are 3 minutes past the hour. So let's start. Good morning, good afternoon, good evening, everyone. Welcome to the last lecture in this four-lecture series on Introduction to Machine Learning. Today is going to be, I would say, very somewhat of an advanced lecture, looking into the art of the possible when it comes to machine learning. So we're going to discuss some advanced topics, and we're going to summarize what we've been discussing for the last almost 5 weeks now. As always, as I'm going through the lecture, feel free to ask, raise your hand, ask questions. I'm more than happy to pause to answer these questions. So we're going to go through an overview of the last lecture. We're going to talk a little bit about unsupervised learning. We're going to discuss something called the dimensionality reduction technique. We're going to talk about model deployment and monitoring, ethical consideration in machine learning, and we're going to wrap up with course summary, takeaways, and then future learning paths. So, what did we discuss in the third lecture? We spoke about supervised learning, specifically regression and classification. We spoke about model training and evaluation, and we had two examples, one with the diamond and one with the flower classification. We went through examples using scikit-learn, and we discussed what it means to overfit the model and what it means to underfit the model, and how both of them happen, and how to prevent um, both of them, and how to also identify what you're seeing, whether it's overfitting or underfitting. Okay, so today for unsupervised learning, what is unsupervised learning, and why is it helpful? So in unsupervised learning is learning from unlabeled data to identify patterns and structures. So, as the name implies, a lot of times with unsupervised learning, we don't really know what are the groupings. We're not sure we don't have enough data, maybe we don't know, and we use certain algorithms like clustering algorithms and association algorithms, like the k-means, the hierarchical clustering, the a priori algorithm, to basically group the market and to group the data. And one of the really good examples is customer segmentation and market basket analysis. You can think of this as, let's say, you are entering a new market and you're not aware what types of customers buy your product. You can leverage something like k-means to help guide you in identifying these clusters. And these clusters can be, for example, men over 40, women under 30, but you wouldn't know these beforehand. Looking at the data, looking at where looking at how you're leveraging these algorithms can help guide you into the best, or the the grouping that makes most sense. And usually it goes something like this, where in a very simple, especially I think k-means, yeah, k-mean clustering, you have certain groups, and usually you one of the parameters you provide the model is you tell it how many groups does it have. So for example, if you gave the model two groups, it would have split it into one, which is the red, and it would have combined the green and the blue because they are very close. Because the user set three as the number of clusters, then it broke down these two into two different clusters. One of the tools that are helpful when it comes to unsupervised learning is dimensionality reduction techniques. And the main purpose of dimensionality reduction techniques are to reduce the number of features while maintaining the important information. For example, here on the graph on the right, this is an example of something called the principal component analysis. So in the in this example, you have two variables. You have x and y, and you can see that x and y are not like they're increasing, but they're increasing not in a not very in a linear way. So as x increases, y increases. What what you can do with principal component analysis is basically change the orientation of the axes so that the x-axis and the y-axis become these new z and y and w. This example is easier or is easier to visualize because these are two um, axes. However, most of the times this dimensionality reduction technique is leveraged for much higher number of variables or much higher number of features. For example, you can have 10 features reduced to 3 or 2 variables. And this becomes very helpful because first you're changing the orientation of the axes so that under you can visualize the the different um, features in a certain way that makes it easier for the model to extract useful information. Another method of principal component analysis is the T-distributed stochastic neighboring embedding. Very similar. Um, I think principal component analysis is a little bit more straightforward, and I tend to use it more often. Again, example is visualizing high dimensional data in 2D. So for example, here, if you could have had many other features or many other variables, and you standardize them into two 2D so that it can be easier to visualize the relationship between the variables. So what happens after you have generated the model, whether it's supervised or unsupervised? How do you make sure that it's actually been used or it's leveraged or it's beneficial to yourself or your end customer? So there's a process called model deployment and monitoring. And this is what it means is integrating machine learning models into production systems. For example, let's say you use Google to search for a specific um, anything now. If you've noticed, um, Google added a new feature where whenever you're searching for anything, the first thing that comes up is a result from Gemini. Gemini is the GenAI algorithm, generative artificial intelligence that Google Alphabet have developed. You see that once you search for anything, first part is the result from Gemini. That is a deployment of a model. Google developed their Gemini model and they wanted to deploy it within a current product that they have, which is Google Search. So at this point, they've deployed it and now they're monitoring. Monitoring means ensuring model performance over time. And if you notice that implementation, you can see that Google is asking for feedback. Let me see if I can do a quick test here. It's it's not showing at this point. Okay. So maybe they stopped the testing. Maybe it didn't work out, so they've removed it. So what are some of the techniques of model deployment and monitoring? There is there's containerization, which is like Docker. There is continuous integration and continuous deployment, CI/CD, and there is model retraining and updating. So the containerization is, I would say, the least impactful in my opinion. Both the second and the third they make most sense, which is continuous integration, continuous deployment, which means you continuously as the time goes, you're continually integrating your model into more products and you're continuing deploying it into more products. Model retraining and updating, as the name implies, you take the model, you make it better, and you put it again. And then, for example, these are some examples. Deploying a model using Flask and Docker. These are tools that you can Google. It shows you how you can deploy a model into your website or even in its own web browser. What are the ethical considerations when it comes to machine learning? Um, and when I say ethical consideration here, I mean really a lot of things. So this is an example of a charter in healthcare, but this can be more generic to a lot more things when it comes to AI. So for example, when it comes to, as an example, healthcare, there is social well-being, avoiding unfair bias, privacy and security. So for example, social well-being, making sure that you don't harm anyone, avoiding unfair bias. Um, for example, with AI, if it's trained on a certain type of people, it can have certain biases towards these people. So, for example, it can be racial bias, it can be religious bias, it can be gender bias. So, whether the color of your skin, it can have bias to that. Your religion, it can have bias to that. Your gender, whether you're male or female, it can have bias to that. Privacy and security, reliable and safe. So privacy, especially with healthcare, you don't want the data to be leaked. You want to make sure that the AI is secure. Reliable and safe, you want to make sure that it does not give you wrong information. Transparency and explainability. You want to make sure that even if it messes up, you are able to clearly articulate how it reached this specific answer. Human centered. Human is at the center of it. Humans need to be the biggest benefactor of the AI. Accountability, we're able to go back and review the answers and make sure that we can improve the model. Value alignment, it is aligned with the organization or with the task that you're trying to achieve. And governable. You're able to have a team or certain individuals who control this model. And here are some of the clarifications: bias and fairness. Ensure model does not perpetuate bias. Transparency, model making models interpretable and understandable. Privacy, protecting user data and complying with regulations like the GDPR. Ensuring responsibility for model decisions, which is accountability. Okay, so let's go over an example of k-mean clustering. Okay, someone text. Yep, perfect. Awesome. So this is an example of k-means. I'm gonna go through it and I'm gonna explain what we're doing here, and I'm gonna also make some changes as I show the model. So here, this is the example of k-means. So the first thing we do is we import the relevant libraries in Python, as we always do. Second is we are importing the data set, which is already in the Seaborn library, which is irises, the same one we used last time. Then we are defining what is the x, and but because this is an unsupervised model, we're just saying, hey, can you cluster them into three clusters? So this is what this model is doing. And then we are saying, hey, iris cluster k means dot fit predict. And then we are fitting this model into three clusters. Again, we don't know anything about this data. Basically, we're saying that the we're removing the y, which is the species, which is the dependent variable, and we're saying, hey, split it into three. And I would like to change this maybe to let's say two. Even though we know that this data has three species of irises, because this is unsupervised learning, most of the times you know the grouping, but a lot of times you don't know. So let's say I decided to do two, and I wanna plot it. Let's see how it looks like. See, so here it split it into two clusters. Even though, if you remember last time, and let's see if I can open this the last time the lecture from last time. So here in the classification one, whenever we did the classification here, we had three clusters, and these were the clusters. We had the Setosa, we had the versicolor, and we had the Virginic. So if I were to come here again, and instead of two, because I know there are three, I come and change this to three, and I say, hey, plot it again. Oh, it did a much, much, much better job. It clustered this by themselves, and this by themselves. Can I do 10? Yeah, I can. And it's gonna split it into 10. But this is meaningless. Because at this point, it's very hard for the model to know what is what. And you can add as many as you want. But this is where domain expertise is very helpful, especially when you're training models. For example, in this case, if I'm working with I would be working with a botanist or someone who knows irises, and I would ask them, how many species do you have? And from that, I would guide the model into maybe three clusters. Any questions on the k-mean clustering? So I see someone raising their hand. I think they lowered it. Okay. So the next slide, I want to go over principal component analysis. And I know we covered it a little bit last time with one of the examples, but I wanted to focus on the principal component analysis for this lecture. So let me just. So again, the intention of principal component analysis is to reduce dimensionality. So here, again, we're doing the same thing, importing the libraries, importing the data set, splitting into three clusters, and then plotting the data. So we should see the same thing. But then I want to take all the x's. So just to give you guys a heads up, x dot head is let's see, capital X. Yeah, these are four variables, four features. And here, what I'm asking it to do is I'm asking it to split it into two components. So, and then I want to plot these components. Oops. And then I want to, so here, PCA, principal component analysis, two, and then PCA dot fit transform. And then I'm asking it to plot these into two principal components. And this is based on unsupervised data. But we added the species because we know the why. Let me show you here where we added the why. Here, iris pca.df. We said that this is the data, and we colored it based on that. And if you remember the example we went through here, this is the same exact code actually, which is principal component analysis. I just wanted to give you context from supervised learning, which is classification last time. And today I wanted to show you the same context from unsupervised learning, showing you that both ways would reach the same output when it comes to principal component analysis. Any questions on the k-means or the principal component analysis? Okay, so as we come to really the end of the class, the end of the course, is what are the course summary and takeaways? What did we cover within the last three lectures and now the fourth lecture in the last 5 weeks? We spoke about introduction to machine learning. We spoke about data preparation and exploration. We discussed how can we build and train a model, and we shared some examples. And we ended with some advanced topics, including unsupervised learning, including the dimensionality analysis. What do I want you to take out of this class? Are we able to get the slides of the training? I would suggest asking I'm more than happy to share them, and I will send them to Dr. Al-Garhi, and hopefully he would be able to share them out. What I would suggest is there are all these lectures have been recorded. These are on YouTube, so you're more than welcome to check them on YouTube. What are some of the takeaways? One of the main things is importance of high quality data. Um, we also learned some techniques for model evaluation improvement. How can we define what is overfit, what is underfit? For some of the consideration of ethical consideration in machine learning, and some practical skills in Python. Again, what I showed you with Python is the beginning. There is so much to learn with Python, and whoever says I don't need to learn anything more in Python, you know that they don't know anything about Python. Python is a lifelong journey of learning. Just Python, even if you're not using it for machine learning, it has so many applications. So I highly encourage everyone to look at Python as a tool that really can be leveraged in a lot of applications. So what are the future learnings? Again, this is the beginning. This class is considering the building the foundation of what is machine learning. And if for you to really benefit from this class is to use it as a starting point to your own learning and your own path, whether it's academic in college or in school, or whether it's on your own, which at this point I feel majority of these things are learned on your own. So you have deep learning. You can learn about deep learning. You can learn about natural language processing. You can learn about reinforcement learning, and you can learn about advanced model deployment techniques. Again, I spoke about a few. There is much more stuff to learn, and here is a very interesting and a very simple diagram of what is artificial learning, which includes everything. what is machine learning, and then what is deep learning, which is machine learning algorithm with brain-like logical structure of algorithms called artificial neural network. And this one is very, very interesting and very advanced and very beneficial. And as the name implies, it is built as a neural network, as a brain neural network. So what do I recommend? What do I recommend for you to do next? Online courses. There is Coursera, there is EDX, there is so many things out there that you can learn. There's also books and research papers. I think this is a some books are really good. Research paper maybe a bit advanced. Machine learning communities and forums. I would say I did a lot of learning through the third one. So I did the first two, but the last one is very, very helpful. Machine communities, competitions. You go in these things, you learn, you see the art of the possible. Some people are very, very advanced, and you just learn from them. So, highly suggest learning from these individuals, learning from these communities, and then one day you can have your own portfolio showcasing your skill set on what you've been up to. So, can you recommend such communities? The community I'm most aware of is Kaggle. Let me make sure of the name, and I'll put it. Yeah, Kaggle.com. So let me just I'll put it in the chat. I put it in the chat. Actually, I'll answer this one. Perfect. So thank you, everyone. It has been an absolute pleasure preparing these lectures. For me, this is a really fun topic, and I'm very grateful that Dr. Al-Garhi thought of me when he wanted to teach this class. I am I'm available on LinkedIn. You can always feel free to reach out to me if you have any questions or any really anything that you have concerns about in your college career, your college or your career post graduation or even school. Um, I've always enjoyed giving lectures and classes with PioPetro. They've done exceptional work over the last couple of years, and I'm very happy to be a part of it and continuing to provide support when I can. Are there any questions? So for link, okay, sure. So some people are asking for my LinkedIn profile. Let's share it. Okay, if that's everything, I will leave you to the rest of your day. Thank you everyone for attending these last four lectures, and I look forward to getting to engaging with you in your future and hearing great things about what you are up to and what you're accomplishing. Have a great day, everyone. We will talk soon. Goodbye.